So hi everybody. I am Francesc Campoy, and we're gonna be giving a talk that is kind of a weird talk, but hopefully you'll enjoy it. And if not, it's the end. So at the end, you still get to drink, so it's fine. So it is not working anymore. Let me click there. Okay, cool. So yeah, as they said, I'm Francesc Campoy. I'm unemployed, and it feels good. And thank you. And I'm here with Matt that works at Google. And basically, he keeps on touching things. And
I'm going to touch it.
Okay, cool. So yeah, 2 years ago, actually 3 years ago, almost 3 years ago now, I wrote a blog post about how to analyze Go with BigQuery at large scale. So basically trying to do like big data but code analysis at the same time. And I did some cool stuff, like trying to figure out what are the most used packages by Gophers in general, outside of the standard library, because otherwise it's too easy, but in general. And I found some cool stuff like this, like glog, loggers. Probably you all know some of these, right? The thing is that in order to write this, I first had to write this. And this is not the hardest regular expression I wrote, not the hardest SQL query that I had to write, but this was actually pretty hard. And as you can see, there's actually two different ones, because import statements sometimes have a parenthesis and sometimes they do not. So yeah, so that was really hard. And if someone tells me it's wrong, I would not be shocked, to be honest. It would not surprise me. So another analysis that I did was, so Dave Cheney wrote this thing saying, Golang top tip, return an interface rather than a private tag, return a public tag rather than an interface. My reaction to this was, does anyone return a private tag from a public function? This doesn't make any sense. Who would do that, right? It's an awful idea. So I wrote the thing. So as you can see, it's pretty straightforward, other than, for regular expressions. And with this thing, I was able to find all of the places where exported functions were returning non-exported stuff. And I decided to go and try to blame those people. And I found Kubernetes. So yeah, it is a common thing. Every single time you think, nobody would do this. Guess what? And I did that. I published it on Medium, and the link will be at the end of the talk. And then almost 2 years later, last year, I went to GoSF, which I co-host to co-organize. And Matt was there to give a talk about if you could grab the contents of every file on GitHub, which I was doing, what would you do? So now he's going to explain a little bit about that.
Cool. I don't need that actually.
Oh yeah.
Cool. Thanks, Francesc. So it turned out that this is actually obviously something that Francesc had been doing, unsurprisingly, at Google before me. Actually, right after the talk, we were actually addressed exactly like this as well.
Yeah.
So you write a lot of regex, and it's kind of cool to find a lot of really neat stuff. But the fun thing was Francesc was actually I've been working on some stuff that makes this a lot easier. I don't have to write still some SQL, but not some really hairy regular expressions, and that's kind of nice. So I want to talk a little bit about how we can do things in a slightly better way. So some of the things I want to talk about is how to find bugs or look at API usage across packages, right? So thinking about across microservice code bases, right? You want to sort of think about consumers of your library as well. And you want to do it accurately. We were just saying, right, the heuristics and things like that for looking at import statements, right? You have to think about, okay, what are the cases I have to keep catching? How do you even know you're missing some of those cases because you're not actually looking at sort of structured data? You're looking at strings and you're trying to sort of string match, not particularly effective.
And also, what happens if the code is not Go thumped, which I didn't take into account. Otherwise, it'd be impossible to write almost.
Yeah, I was saying just if it's not formatted, thumped, sorry. I'm just going to leave it and let it be, right? So this is the previous state, looking, files are just text in basically online database, there are megabyte for each sort of row in the column. We're running a bunch of little expressions, and it turns out that
that's my name.
Actually, Francesc used this in a particular project, in the Go project itself.
Yeah, so basically we had a proposal to say, should we add time.since? to the standard library. And basically the question is, do people actually need this at all? Are people actually writing that pattern that we replace? And I was able to prove with that indeed, yeah, and actually a little bit below, I also proved that most people also did it wrong. So it actually made sense. Like I was able to find some bad patterns that were there and people were getting that wrong. So it actually showed with data that it was a good idea to add that function to the standard library. And I think that it's still there. Or it was removed later on, but it was sad for me. But anyway, this is the issue.
And you can see like it gets really ugly trying to find sort of like methods on packages, and people are providing digits and like parsing things incorrectly. Like again, it's sort of heuristics on top of regular expressions, and like that's not particularly great. I'm counting for indentation, or as we just said before, if it's not formatted, hoping for the best. Right, like if only my query knew what a function was, or a method was, or like a type was, like a type declaration, that'd be awesome, right? And I don't want to write regular expressions. I just want to say like, show me the types, show me the methods, show me the functions, and give them back to me, right? And let me go and filter those. So again, obviously, like what we're looking at is like not great. It's not accessible. Like writing good and like decent regular expressions, let alone performant, is its own skill. So I want people to like ideally be able to do this on their own without having to consult some huge manual or learn some other language. So again, can we improve on this? So now get to the real part, which is like what this talk is actually about. And Francesc.
So imagine I give you this task. I tell you, you have all of the source code on GitHub, and you need to find what is the most common string literal. So think about that for a little bit. How would you do this, right? And then the first question would be, okay, so what's a string? Well, a string is something that looks like this for some languages, Python, for instance. Like this for some other languages, Go, for instance. Like this for some other languages, like Python. Like this for Go. No, that is Java, I think. Python 2, that is Go. This is apparently some weird languages have used this in the past. Also, did you know that's a character? That's a thing. And finally, Perl. So, it's actual Perl. I did not make that up. So yeah, imagine having to write the regular expression for this, right? Just that is like, ooh, that's scary. And then on top of that, just the fact that, it's regular expressions and XKCD for everything. So yeah, if you had 99 problems and you have regular expressions, now you have 100 problems. Once you have that, you're just like, oh, strings. Okay, I figured out it should be easy. Cool. So yeah, how do you escape characters? Yeah, XKCD for that. I will not read the whole thing. I will just say the last one is the true name of the soul eater. So yeah, it can get pretty complicated quite quick, right? And then if you think about this, the way you start a string needs to be the same way you finish a string. So you actually need to match things. And regular expressions cannot do that unless you have a thing. It's called recursive regular expressions. Recursive regular expressions. It is awful, and I will not use it ever in my life. If you've ever done things like language theory and stuff like that, it's super fun to play with. Not in your production code. So how can we do better than that, right? And the idea is that when you are analyzing programs, normally you do not just do regular expressions, right? Like the Go compiler does not do regular expressions. What we do is we parse, we get a thing called token. Well, we lex the thing, we get tokens, and then we parse them into a tree. And you get that abstract syntax tree. So the idea is to use that instead, that level of abstraction, instead of just the regular expressions. So the idea is that, for instance, here on the left side, my right side, your left side or something, is the code that says hello Gophers. And on the other side, you're going to see a tree. And this tree corresponds to what the code is doing. It's not complete, because otherwise it would be pretty large, but this is basically what the code does. Cool. The idea is that once you have that, well, why don't you do the same thing with other languages? So now you have Python, and it does kind of the same thing. So the idea now is we have this format of, we have one way of storing abstract syntax trees. And once you have one single format, you can build tools for all of the languages because you have that single format. And that format is nothing else than just one way of doing protocol buffers. So it's not complicated. It's just agreeing on how we're going to store abstract syntax trees. And we actually call them not abstract syntax trees, we call them universal abstract syntax trees for that reason. The fact that there's one format for all the trees. But on top of that, there's another universal aspect of it, which is the fact that you have also a concept, a list of concepts, right? So you agree on what's a string, what's a function, what's a boolean, all of those things we all agree across languages, more or less. We're gonna make those part of the labels that we use. So then, when you have a tree like this, you can actually say, hey, give me the universal abstract syntax tree, the label that says string. And using XPath, you can actually identify which ones correspond to that. The same idea, you can do it with Python, and it would work exactly the same. And with the same expression, and that's the whole point, right? Like you're using exactly the same expression. You're just saying, give me the strings. You're gonna get the strings no matter what problem language you are. So with that, there's the query that if you run it over all of GitHub, will give you what is the most common literal string in all of those languages. But that takes a while, so in the meanwhile, back to you.
Thanks. So, backstory, like, how do we run this across, when Francesc says, like, all of GitHub? That was kind of the original plan. Turns out that roughly with 8,000 Go repositories, 85 gigs of data, the tooling really couldn't keep up, and that was on a 96 core VM with 360 gig of RAM and a RAM disk. Like, we tried everything to try and make this work. Queries would take hours. So, tempered our expectations, came down to about 1,000 repositories. So pulled down the top 1,000 repositories in Go, ordered by star count, because that's really important. Just kidding. And just the head, obviously we didn't want like all lots of brain, just wanted to sort of keep it a little slimmer. Still about sort of 18, 19 gig. Parsed them into basically SQL tables using the source detooling. So I'll tell you a little bit more about that.
Sourced,
sorry. Australian accent, that's how we pronounce it.
Oh, yeah.
And we wanted to sort of explore a few hunches, right? We now have this like structured representation of the code that we kind of wanted in the first place. Can we do a little better than we were doing before? So we had a few ideas, right? Those hunches were sort of finding bad code, things like code smells, maybe like misuse of things. And I say bad, like things that are like bad maybe for the consumers. It's not actually like a call, like a sort of a label, I guess, on the programmer that's doing it. People don't always know these things. Best practices and idioms, and like importantly for me as like a maintainer, is looking at how others are using my APIs and my packages, right? Like that would be really cool to try and figure out some of those things too. So, finding bad code. So, bad crypto, we've all heard of it, hopefully. If you haven't, like I'd love to be in that world, it'd be really cool. It's still really hard to get crypto right. There's a lot of folks out there like trying to make it easier, like write great documentation, examples, things like that, right? And like remove all those sharp edges, right? Deprecate. I think Filippo's like trying to deprecate like half of the Go crypto packages. Good luck. It's honestly like great work.
He looks so happy.
But there's still a lot of existing stuff out there. People interfacing with legacy stuff. People are just like started writing this code before like Filippo came on board, right? How do we like go and fix that kind of stuff, right? How do people know like whether to use a hash function or a KDF?
Quick question, other than Filippo, who knows what a KDF is? Stands for Kentucky Derby Festival. I searched on Google.
I'm not going to tell you what it means because like that's the kind of the point is, right, like if you don't know what it is, how do you even know that you should be studying it? Most of you probably think like passwords, hashes, sounds good. So again, for those of you thinking like, hey, documentation sort of explains these differences, right? Like, cool. You start reading the docs, right? Like, do you even know which random package this is actually for? Is this actually the right one? It turns out that it's not the right one. And if you read package documentation like me, like you read the first couple lines, you're like, this is what I want to use, get some stuff to do, let's go move on, right? Turns out like, actually, this is the one that's not for security sensitive work. But also that can be interpreted in many ways. Most people may not think of the things they're doing as security sensitive. So, with that kind of like setup, right? how can we go and find some of these cases? So we can structure things, right? And this is like the core of the query we're looking at, right? So we're basically looking at the blob content, so blob as like a get construct, the file contents in many ways. We're basically doing some auto detection of the language with the language function. So we're looking at the file path and the content to try and determine that. Let's go. And then we're grabbing an array of all of the identifiers for each of those files. And that's just basically those functions. We're grabbing the names. Beyond this, obviously, this is a small abstract. We're just going through that array and looking for the particular functions that we want. So we're looking for the, say, MD5 and like MD5.sum as identifiers together as well. So pretty easy to grab those out of the final array, right? I'm not having to write any crazy regular expressions. I can just do some really simple string matching to grab those things very precisely. Indentation, not a problem. Don't have to worry about casing, all those kind of things, right? Like if the identifiers that the public exported, we don't know what they look like. Again, no regular expressions, really cool. So, with that in mind, Francesc wants to show you sort of another example.
Yeah, so Twitter. So I tweeted this morning to try to cause some drama, and it worked. So basically what I was asking is that, okay, so we all know that init function is a thing that exists, and it's cool. And it's actually, weirdly, the only function that you can define many times in the same file, only it's in the same package. So that's kind of cool, but how many times is it too many, right? Like if you have one init, is it too much? If you have 200, how many inits is too many, right? So I tweeted this, and the answer was 1 is already too many, which I somehow agree, and actually the community in general agrees that it's not a good idea to have, right? Then you have more than 1, 35%. Those are the reasonable people, actually. And then you have some people that are like more than 20, and then some people say, oh yeah, more than 400, you know. That's what Sure. So some people came and thought leader. So Peter Bergen said that, yes, he did. So init's only purpose is to mutate package global state. Global state is evil, therefore init is evil. Sure, that makes sense, and I understand that. Cool. Some of the people, Nick Finch, said something similar, right? Like, it is bad in general, you don't know when it's going to be executed, the order is random, so it's dangerous. You should probably not use it. Cool, so don't use init. Cool. So, I created this, and I wrote, the thing, Scotty, was what I'm doing here. This is the most complex XPath expression I've written in my whole life, and hopefully the last one. This is a get all of the function groups, find those for which the identifier inside of the alias is init, and then return all of those identifiers and count how many you have. So per file, I'm counting how many init functions I have. Cool. So, yeah. This takes some time. Actually, I went to bed, and also this morning. And I saw this. Great. So that's basically saying that people that are saying, oh yeah, 0 is the perfect number, or 1 maybe, they're basically right. The average is 0.12, right? So only 12% have one init function. Cool. But this is CSI Gopher. So I was like, okay, let's zoom in just the first one, right? So actually you can see that, okay, so 0, there's a bunch of them, 1, a little, some of them, and 2, some of them, and that's pretty much it. But if that's the case, why is the previous graph showing up to 350 something? That's suspicious. So you change the scale to logarithmic, and you see this. Yeah. Yeah. That's scary. So when I saw this, my first reaction was to tweet about it, obviously. But after that, I was like, okay, so this is wrong. Hopefully, like, this is my code. The query is wrong. No one would ever do this. Do you remember what I said about no one would ever do this? Functions. It is a lot, but also it's weird that there's all of these files have 352 exactly. That is weird, and they also have the same name, enum.go. So I was like, oh, vendoring. That has to be something that is vendoring to all of those repositories. So maybe actually Kubernetes is not to blame. They're just using a package that does this. Okay, so it's actually VMware. And there's this file here that contains 352 initializations, and they actually look like this. And the thing is that in every single init function, they're putting something else in a map. And this seems crazy, except for the fact that, hopefully this code is automatically generated. It doesn't say so, so I don't know. I really hope so. I really hope for the person behind it that it's auto-generated.
That's part of it.
Yeah, but okay, so this is actually auto-generated. But the important thing about this is the fact that actually someone one of my ex-coworkers came back with this, and it's like, what about initializing resources that should be initialized at the start of the program and live there and change for the rest of the program's life, which is exactly that use case, right? And the cool thing is that I had not thought about this. I actually thought about this when I saw the data, and I was like, 352 init functions. These cannot be good. Actually, it's fine. Why not, right? It is surprising, and I would write some warnings at the beginning and make sure that it's actually like, hey, don't touch this. But it's actually okay. So my idea was basically saying, we all say that we are engineers and science and all that stuff. Let's actually do science, and let's provide the data. If you have a hypothesis, such as init functions are bad and you should never use them, actually prove that that's the case and that people don't do it. And if they are doing it, figure out whether they are wrong or your hypothesis needs refining, right? So I thought that was pretty impressive, to be honest. And for the last part, back to Matt.
Great. So, as I touched on earlier, one of the things we also want to look at as well was API usage and thinking about sort of how we might want to break some of our APIs, right? And this sort of came up in the context of you were a popular, maybe unpopular open source maintainer. You got a library that's got a couple of stars, doing pretty well. And you're thinking about deprecating some of the methods, right? Go modules is out now, so those kind of breaking changes much easier. You probably don't want to do it all the time, but there's definitely cases as things have grown organically over the years. Maybe you sort of took over maintainership, and okay, look, I want to clean some things up. There's some things that maybe some pull requests that I really wish I'd said no to back in the day, but here we are, right? But you got some gut feels. You think some people, have a hard time, some issues get created, and there's lots of sharp edges. But you're okay, great. How do I go and get data on this? How do I actually go and find, who's actually not using these things, misusing them? Also another good reason. We can probably go and do a little bit of talking to people, see who's importing our packages, right? But that's pretty manual, pretty slow. I know Godot can show you importers and stuff like that, but imagine crawling through potentially thousands of consumers, if not more, right? That's going to be pretty hard. So, actual problem, and this was something that actually was fairly close to me. So I co-maintain part of the Gorilla Toolkit. It's a web kind of toolkit framework for Go. I am not the original creator, so the sort of idea of taking something over that's grown organically is particularly relevant here. And people obviously can't foresee everything in the future. So there's a package called Gorilla Context. It's a global request map for stuffing data in for each request. It predates Go 1.7's request context. You need it in someone to put data on as a request. Things go through middleware. You go great and you put a user ID or the state of a user being authenticated. Pretty common, lots of other languages. Go didn't really have a great way of doing that, sort of implicitly. So it's cool. And if you sort of use both together, use Gorilla Context and the new context, you actually can get memory leaks, right? What happens is that request context will shallow clone the request, gets a different address, the old address is islanded, and that's not great. People obviously wrote in in those cases, right, and hey, what's happening? It's well, I know the fix. It's documented here, don't do this. But how can I proactively go and find all those users and actually help them through this and get them off this library or make sure they're not doing the wrong thing? So super quick explanation, right? Lovely global request map. Definitely not the thing you should be doing today, but back to Go 1.1, those are the tools we had. And you can see obviously the request pointer there. So what happens is when you shallow clone the request in the bottom code, which is from the Go standard library, that address, the map key changes. And when you want to clean it up at the end of the request, as you would normally do, you're no longer cleaning up what you put in the map, you're cleaning up something else. And that sticks around, and it sticks around, and it sticks around, and it basically grows. And you might crash your application, or wonder why your memory usage is increasing over a period of days, or maybe hours if it's high velocity. And So our goal again is like, can we go and find these kind of cases? So what we have here is a really, really accurate way of finding the import paths. None of this like, I'm looking for parentheses in import paths or no parentheses, or like, did someone like go func their code? I don't think about it anymore. I can just go, hey, extract all the cases where like in the universal abstract syntax tree, import path, give me the value of that, and just make sure that the obviously the array is not 0, and then I get a nice array of those imports, and I can just like check the membership of that array for the library I have. Much, much easier. Like I can obviously look for repository IDs, file IDs, things like that. And now I can potentially use some tooling to automate like reaching out to those users saying, hey, like I noticed in this file, like right here that you're importing this, like here's a better way to do it. Like, I can write a little bot that maybe can do those kind of things as well. So, sort of the other way to do it is like we're looking at, right, not so great, much fuzzier, probably not going to find everything, and in many ways can also be much slower. Great, so we went through some, I think, hopefully 3 pretty interesting cases. And like what else could we maybe do, right? Like what are some of the things we could do with like tooling like this? So rather than just like an alphabetical list of identifiers, right? So if you're using GoDoc and everything's generally sorted, and you see a bunch of like Earth something at the top of it and a bunch of constants, and it's like you scroll all the way down to actually get to the useful stuff. It'd be really cool if you could look across all the package users and sort that GoDoc by usage and go, okay, like these are the types and the methods and things that are actually used the most, and put those at the top. That'd be really cool. That'd be great for like discovery. It'd be great as like a maintainer. You're figuring out like what people are using the most, and again, it goes back to thinking about how you make changes or how you maybe improve documentation. Right? Is no one using like my foobar fun function because it's poorly documented? Does it feel a special case? Maybe that's true, right? But you can validate those things a little bit with some data. It's not possible today with USD, although they are technically Go files. It's just that like the parser doesn't recognize the structure yet. But you can obviously look at, like, say, Go mod files, right, and think about like dependency skew, which would be really cool. What is the version of my package that people are pinning in their Go mod files across all of the consumers, right? That'd be cool. There's actually, from memory, I think about 2,200 repositories using Go mod at the moment, which is pretty good. I've been tracking it like week by week for the last like 8 months. So it's been a pretty good progression with that. So it's pretty cool, but people probably like start this up, generate a Go mod file, get a version, and then maybe they don't upgrade, right? And maybe it's a security issue, maybe it's just like you make things a lot faster or better. Like, how do we go and like find those things? And one of the other cases, like Francesc mentioned, was like the idea of...
Yeah, so one of the ideas was there's many APIs that you actually need to use in a specific sequence, otherwise you're doing it wrong, right? So for instance, what is the first function that you should be writing in your main when you have flags? Flag.parse, right? If you don't do that, you're missing out. So it'd be great when you write flag dot that it says parse, right? It's like, you need to write this first before you do anything else. So let's get it done, and then actually suggest the things that, well, once you've done flag.parse, why would you suggest again flag.parse? There's no point on that. So put it at the end of the list.
So, although I couldn't use UASD, I did use like BigQuery and a bunch of horrible regular expressions, and I'll show you that in a second. But the nice thing is like this is the kind of representation I would love to be able to get in a really structured way, and go and find like who's using 1.4. It's terrible, just lying, but like I can go and say, hey, like the Blacktop project, go and find out and help them upgrade things like that as well, right? And it'd be awesome if you could automate that.
Just Kubernetes.
I'm kind of proud of that. And seriously, like if anyone would like to go and build a bot or like do something with this kind of data, like please reach out to us, and like I'm happy to like give you the queries, give you some of the data, and sort of like help you. Maybe you want to like build a GitHub bot that like can troll through for a list of packages and like ping people when they're like potentially like a major or minor version out of date, and sort of convince them to upgrade if they'd like to, or people can opt in for those kind of things. This was the query. Intentionally goes off the slide. That's kind of the point. It gets real messy, lots of joins, lots of lovely expressions, and it's just getting it for one package. And honestly, it probably doesn't even capture all Go mod variations. I didn't even read the spec in full. I just like iterated over a few versions, so I wanted to like get a quick list. For this to do it sort of like comprehensively is probably going to be much hairier. So just a real quick bit, obviously I want to share like some of the tools we use and like where you can find them. So use a bit of BigQuery. We use the source engine as well. Lots of RAM, lots of CPU, lots of time. We actually both had like big instances to try and like crush this out. And like Francesc said, went to sleep and had to wake up to get some of this done, which is like kind of fun, but not a great feedback loop. Hopefully we can like make that better. Obviously these slides, my old talk and Francesc's blog posts are all accessible as well. So bit.ly/Gopher.
So yeah, so at the beginning I said, what about those strings, right? Like you are parsing all of the strings in the world. So this took a long time, like a long time. And this actually on the 1,000 top repositories. I tried to run it on the 8,000 top repositories, and I decided that actually the conference was today, so that wouldn't happen. So yeah, so it actually is many hours. But so I run this thing, which now that you understand how it works a little bit, it's actually not that complicated. What we're doing is we're calling UAST to extract the universal abstract syntax tree of the content, given the language, and extract all of the strings. From there, we extract the values, and then we just basically return them per language. So that's the idea. So once this is finished, we have the most common strings in Go. And for one Gopher, who could guess what is the most common string in Go?
Error. Or empty.
Yeah, empty string. Number one is empty string with 1 million and something. That is the empty string, which is, by the way, written in Python, just in case. Number two.
ID.
ID. Okay, that's a good guess, but it's wrong.
Hello.
I actually forgot which one it was.
I know.
So I'm good.
Space.
I think it's something. Font, yes, because import font appears so often that string is actually super common. Forgot about that. And number three, you're not gonna guess it. So we all love JSON, except that we don't like things encoding to JSON. Which is interesting. Like maybe by default things should not be encoded to JSON since we write it so often. Maybe. But I'm not sure about that. Just for completion, actually that also returned a bunch of different languages. These are 4 of the most common ones that we saw in the repository. And so the interesting thing is that this is Python that appears in Go repositories, right? So that's very specific.
That doesn't count.
So that
public doesn't count.
So the thing here that you can see in Python, auto manage or visibility public or Go _library. If you've ever worked at Google or you're one of the weird people that uses Bazel outside of Google, you might recognize that. Turns out that Bazel, the Bazel language, is Python. So yeah, so it's actually just Python. So we recognize it, and that's why we found so much Python. In Ruby, we find the break, like line break, which I guess makes sense. I don't know exactly what we did with that. Empty and then shell, and I think that pretty sure that's from Chef or some other tool that uses Ruby that looks like that. And then for Java and PHP, there's so little of that in our repositories that it's not really meaningful. But that same query with a larger data set, we've returned something that is actually useful. And that's it.
That's
Thank
it.
you.